Okay, let's go ahead and get started. We waited long enough. Okay, so everything's streaming. Perfect. So keep track of your assignments. Assignment number 2 should already be graded. Number 3, I should have probably made that due in a week, but for whatever reason I made it a 2-week assignment. So it's technically not due today. I'm guessing most people already finished it though. Show of hands, how many people already finished assignment number 3? Okay, yeah. Usually what I do is, so I'm consistent with the grading and I have a good sense of where the class is, I usually try to grade everything all at once. So even though a lot of people have already submitted it, I will usually wait until after the actual due date, because it really wouldn't be fair for me to put out a due date and grade ahead of time. So there's that. And then there's a new assignment today. Hold on one second. Okay. There's another section of this class on Tuesdays. I think I messed up one of their due dates, but I'll check that out later. But anyway, so this is going to be due in 1 week. It's not going to make a whole lot of sense just yet. It'll make sense after the lecture, but just keep in mind that we're going to have an assignment. And I'll explain it when we get to that example. Not really a whole lot to say just yet because it's pretty early in the semester. Any questions on anything before we start? That's good. Okay, so let's get right into it. Now I have 4 examples, maybe 5 planned for today. I would like to, maybe the last 15 minutes of class, give you a chance to at least kind of get started on this homework assignment, because in the past there's one part of the assignment that sometimes people make mistakes or don't understand, and so I want to give you a chance to read through that and get a sense of it. So we might end about 15 minutes early, but that's not to say that we're ending class. It's just that I'm gonna give you about 15 minutes to start the assignment. Okay, so just keep that in mind while we go through. So let's start with our hello world, and let's just kind of review something we did last class to get into our mindset of writing code. Okay, I'll try to keep this font size. I may have to make it slightly smaller as the lecture goes on, but we'll see how long I can keep this font. Okay, no dropped packets. Perfect. So let's do, last time we did area of a rectangle. Let's do volume of a box, which we've already done, but this version is going to be where we check to see if we have negative values. So what are the 3 pieces of information I need from the user to calculate the volume?
Height, width, and depth.
Exactly. And so we'll, just to stay consistent, we'll say length, width, and height. And then those are going to be variables because we're going to have to take that information from the user and store it somewhere. What data types should those be?
Doubles.
Doubles, exactly. So why a double versus an integer?
Allows for the decimals.
Exactly. So somebody might want to enter in a unit of like 1.5 units, or whatever they happen to be. It doesn't really matter too much. So we're going to make these doubles. So we're going to have length, width, and height. We're almost there. What other variable do you think we might need? We're calculating volume of a box. So what are we going to give to the user? We're going to ask for length, width, and height. What are we going to give to them? The volume. So don't you think that might be good to store as a variable, because we're going to calculate the volume, store it, and then give it to the user?
Sure.
So let's ask them for this information. We've done this a bunch of times before. We do couts. This is usually in the point in the semester where people start to forget some of the week 1, week 2 stuff that we did. So don't forget what endel means and why I might be omitting that piece of information. So that new line at the end, I'm omitting that because I want to keep the cursor on the same line. But remember what that means. CNs, make sure you know the arrow direction. Make sure you know all these basic patterns. Again, this is the part of the semester where conceptually people understand everything, but it's like as time goes on, you start to not remember as well some of the early stuff. And let's go ahead and test this. There's not a whole lot to test, but let's actually, you know, at the very least make sure it compiles and it takes in information. 4, 5, perfect. Now to actually calculate the volume, that's very straightforward. We just say that the volume is equal to the length times the width times the height. The issue that we run into, just like we've run into in the past with the area of a rectangle, is that I could enter in invalid values and it's going to correctly calculate that in the sense that -3 times 4 times 5, that's the correct value, but we might want to do some input validation to make sure that they can't do that. So, okay, we can say if the length is greater than 0, only then do the calculations. I'll give myself a little bit more room here. There we go. Else, cout invalid input. But that only works for length. And if any of the others are invalid, it goes ahead and accepts it. So with the rectangle, what did we have to do to be able to check multiple things?
The else ifs.
So, well, what if we wanted to check in all one statement that everything is greater than 0? Yeah, the 2 ampersands, and so that is the word and. So we're going to say if the length is greater than 0 and the width is also greater than 0. But now we have a third item. Say, and the height is greater than 0. So there's 8 different possibilities, what we call permutations. And the only one that's going to proceed is when length is positive, width is positive, and height is positive. You can look at any other permutation of that, ordering essentially, where I have all 3 are negative, 2 are negative, 1 is not. Any permutation of that, they're all going to jump to the else. The only one that's going to work is when all 3 things are true. Remember that these evaluate to true and false values. It's either true or false. If it can't be evaluated to that, then your code is just not going to compile. Okay, so we have if all 3 are positive, We say volume is, and let's we're not going to test all 8, but let's just make sure that the correct case works. 3, 4, 5, that works. And then let's just try just a couple of them. So when they're all negative, that worked. I'll try one more. Okay. Any questions on that? Anybody need another minute or so to type? Sounds good. Okay, so let's go on to another example. So that's and. We also have or. And the way or works is that if one thing is true, or the other, or both. We'll get into that in a second. So let's go ahead and just write our boilerplate code here. And in this example, I want to use string. And remember, when we use string as a variable, we have to include it. So up at the top here, I'm going to do include string. And so I'll set up the basis of the program. The program is going to be, you know how if you go like to the movie theater or restaurant or something like that, they'll have various discounts. And so they might have a veteran discount or an AARP discount. And so we'll just concentrate on those two. And the basic idea is that if you're AARP, you get 15%. If you're a veteran, you get 15% discount. If you're both, you still only get the 15%. It's not like they add or stack on top of each other, okay? So that's the basis of the program. So let's do that. So we have a couple of variables. So we're going to ask them if they're an AARP member or a veteran. So that's where we're going to store those. Now, normally I don't particularly like to do yes/no questions. We're just going to, there's some problems with case sensitivity, and I don't want to really get into that right now. We will do a yes or no, but we're just going to keep it simple. Okay. So the first thing we'll ask is and let's go ahead and test that. It is case sensitive, so you have to type in yes or no in lowercase. So we would say yes. Okay. Same thing with, are you a veteran? Yes, no. So we'll test both of these. Not going to really do anything yet, but make sure at least our code compiles. So nothing interesting just yet. All we've done is ask them if they qualify for either one of these discounts. Now we're going to say if AARP equals yes, we'll see out you get a 15% discount. Let's just test that. We want to go one piece at a time. We don't want to try to do too much. So if they do yes, correct the case sensitivity. Okay, you get a 15% discount. But we need to also test to see if they're a veteran. They don't need to be both, so we're not going to use an and. They don't need to be AARP and a veteran. It's an either or thing. So if they're AARP or veteran, if either one of those is yes or both, and the way we write that is that we use these two vertical bars. Sometimes we call them the pipe. And that means or. So the two ampersands mean and. This means or. And then, as always, let's always have our else at the end. I think most people know, but just so you know, AARP, it's just a retirement membership type thing. American Association for Retired Persons, I think is what it stands for. Okay, so let's go through this. So let's say, for example, I'm neither. That should be the easiest to conceptually understand. You do not get a discount. So there's four possibilities. There's yes, yes, no, no, yes, no, no, yes. Everyone agrees? So let's start to go through the possibilities. We already tried no, no. Let's try yes, no. It worked. No, yes. That works. The one that throws people off is yes, yes. The way it works is if this is true, or this is true, or both can be true. Now, when we talk about ors in English, we don't really. So, for example, if you're at a restaurant and the waiter says, "Would you like soup or salad?" Do they generally mean soup or salad or both? No, they generally mean one or the other. It's actually what's called an exclusive or. It's one or the other, but not both. In programming, it tends to be most convenient to just have a regular logical or, where we say one or the other or both. So in this case, they can be AARP or veteran, or if they just happen to be both. But of those three possibilities, all three get them a 15% discount. The only one that doesn't is false, false. So when this is no, no, then it jumps to the else. Everyone good with that? By the way, just kind of as a side note, this is the reason I don't particularly like to use these. So they're case sensitive. So if I wrote yes in all capitals and yes in all capitals, notice that it says you do not get a discount. What I've seen students do in the past is and so you can chain these together. and I've seen people do like 15 different checks to see if capital Y, lowercase, lowercase, capital, 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 all the different ways that you could arrange it. In practice, what you have to do is you have to go through every single letter and convert it to a lowercase and then do the check, which we don't really have all the tools for just yet. So we'll just pretend like they correctly entered in. But these, generally, I don't really like these yes/no based questions because we don't really have the tools until later in the semester to do that sort of thing. However, in like week 1 or 2, we can, maybe more like weeks 2 or 3, we can check to see if choice is equal to 1, but when it's an integer. So just to let you know that these are case sensitive, so that's why this didn't work. Okay. Everyone's good with that? So 2 ampersands, that means and. Both things have to be true. With an or, it's one or the other or both. Okay. So let's start another example here. This example is going to serve as the basis for your assignment. It's very important this is recording. Okay, perfect. So in this example, there's a few things I'm trying to show. But the basic idea is that we're going to, so like if you go somewhere and you're buying something by the pound or by the gram or whatever it happens to be, some unit of weight, is that very often you get bulk discounts. So what I mean is if you're buying 10 pounds of it, you'll pay a certain price per pound. But if you're buying 30 pounds of it, the price per pound will be lower. Everyone's familiar with that? Okay. So we'll just, it doesn't really matter what we're buying. Let's just say we're buying sand. Doesn't really matter what. But let me give you the rate table. So we're going to say from 0 to 10 pounds, it's going to be $2 per pound. Now there's some issues with some of this. I like to write programs with mistakes or things that are sort of unclear because in the real world you don't get perfect programs. So if you see some issues with it, just wait till we're done, and then if you still see issues, then you could say something. But some of these I want to work through. So we'll say line these up. It'll be $1.75. And then let's say past 100 we can't do an order that large. Okay, so we can do up to 100 pounds, but we can't past that. We're going to have to send them somewhere else. We just can't do an order that large. Okay, so we know they're going to purchase something, so they have to tell us how much. So the weight. So we'll say double weight. And then we're going to have to calculate the price. So we'll put that there as well. So the first thing that we obviously have to do is get the weight from the user. So we'll say enter weight, and we'll just assume they know it's in pounds. And like I don't usually like to, well, it's not a good idea to write too much code without testing it, so let's just say 5 pounds. Okay, it compiled at least, it's something. So let's start to implement this rate table of the different rates. So we're going to say if the weight is greater than 0, we'll just pretend like if somebody shows up and they want to buy 0 pounds of something, it doesn't really make sense. So we'll just assume that they have to do greater than 0. And weight is less than 10. So if we want to check to see if a number is between two numbers, this is how we do it. We say if weight is greater than 0 and weight is less than 10. This is how we check to see if it's between. That's not really how we read it in English. How might we read it in English? We'd probably just say if weight is greater than 0 and less than 10. But we can't write that in code like that because it just won't compile. Okay, so one thing to note on this is that we do have to be very, just because we're using the same variable and we might read it in English different, we have to, just like this, be very specific, okay? Okay, so we have that. We're going to do something. And then else if the weight something 10 Does anybody see a problem with the way that table was written above? What issue do we run into?
You have 10 variables with 10, or 2 variables with 10.
Yeah, sort of. What was your answer?
If you input 10, nothing will work because it has to be greater than or less than 10.
Yeah. So both of you are on the basic correct, and that is correct. And that's the other thing I want to get into, is that the way we've written this, in the real world, this might work. If a person is at the cash register, they might be able to interpret this because the chances of getting 10 exactly are very low. And so they might, that little tiny amount, they can interpret it however they want. However, when you're telling a computer something, and this is, by the way, this is the real world scenarios that you'd get something like this, and they would say, okay, right now we have a manual system with cash registers. Turn this into an automated process where it automatically determines the price. And so we kind of have a weird thing because we've got 10 twice. Now in this case, what I'm going to say is that we're just going to make the executive decision on, so what we'll say is weight up to but not including 10. So it'll really be up like weight 0 to 10 not including 10. So if you had a number line, it would be the circle, 0 to 10 with the circle saying don't include 10. But as you were mentioning, what happens here is that I can say up to, but not including 10. And then here I'm saying greater than 10. What if we enter in 10 exactly? We've got a little gap, right?
It'll default to
Whatever the else is, yeah, at the end.
invalid input is.
Correct, yeah. So what we have to do is if we were to think back to, I don't know when they do this, maybe high school. Remember the number lines? And then you'd have a circle if we were saying up to but not including, and we'd fill it in if we were including. Think about it like that, is that we can't have, it's got to be smooth all the way through. We can't have any gaps. So here we have to say greater than or equal to. That way 10 is covered. And then we'll stay symmetric here. We'll say, and weight is less than but not including 50. Question?
Yeah, on the initial if, on the less than 10, could it be less than or equal to, and then on the next, on that else if greater than 10.0?
Correct, yeah, either would work. I just kind of made the decision to do it like this, but as long as there's no gaps. Now, that's good you say that because the thing you don't want to do is this. Why? It technically works. We don't have any gaps. The reasoning not to do that is that it's kind of confusing. Because imagine if you would actually draw this out, you'd have two filled in circles, and it's sort of unclear. Now, the code is deterministic. It is going to run a certain way. It's going to pick this one, but it's just kind of like you've got some overlap and it's a little bit unclear. So you kind of want to think through these problems. So in this case, we're going to say up to but not including. But you're right, we could have just as easily said this, and we still don't have any gaps. So that worked just as well. Okay, and then so we're going to say weight is greater than or equal to 10, and weight is less to but not including 50. Keep on filling this out here. Else if weight is greater than or equal to 50, and weight is, we'll say 100's kind of a weird case. We'll just say to and including 100. Otherwise, we'll just say, we'll give a very generic invalid weight. What we could do is a separate test to say over 100, and then, oh, if it's over 100, then we want to send them to a different store. But rather than making our lives difficult, let's just say invalid input. So we can't really test much, but at the very least we can test invalid input. So let's do that. So if we enter in minus 10, invalid input, and if we enter in 300 pounds, invalid input. Okay, so we got something working. So let's just concentrate on this first. So we want to calculate the price. So we're going to say price is equal to the weight that they gave us times, what's the price per pound here? $2. Now we could just write 2, but just to kind of reinforce in your mind that that's $2, you can write it like this. By the way, notice how we're coding. It's very often the case that I always tell people don't code one character at a time. Write skeleton and scaffolding type code and then go back and fill stuff in. It's much more productive to work like that because you can think at like a higher level. You're not thinking one character of code at a time. You're thinking, okay, tackle this and then do that and then do that, rather than trying to do everything all mixed together by writing code one character at a time. This was $1.75, and oh, sorry, this was supposed to be $1.50. So it's supposed to go $2, $1.75, $1.50. So we'll write that here. So it does something. We don't know if it actually works yet. So don't type this just yet, but what we could do is see out price is price. So don't type this. I'll have you type in a second. And this should be 5 times 2 is 10. If we do 20, that is correct. And then Let's do 100 exactly, just to make sure that works, because the math works out easy. Oops, so, yeah, that didn't seem right. So it's always good to make mistakes. What mistake did I make on line number 26?
You forgot to put the weight.
Exactly. So it's not just that the price is $1.50, it's the weight times $1.50. So let's test that again. By the way, that's one of the reasons to test code. Don't just assume that you wrote it correctly. And if I enter in 100, it should be 150. Perfect. Anytime you have duplicate code like this, it's a little bit of a red flag. Now, this is a very trivial example, but think in a very large program with tens of thousands or hundreds of thousands or even millions of lines of code. What if for some reason I didn't want it to say price is anymore, or let's say, for example, I wanted to translate this into another language. If I changed how this is phrased, how many spots would I have to change? I'd have to change in 3 spots, correct? On line number 19, 23, and 27. Now, this is a very small program. That's not a huge thing to do. Imagine it's a large program and this string, prices, whatever, it's spread all throughout your program. And if you decide to change the phrasing, you've got to change it in 3 spots, but they're spread throughout your code. It's going to be very difficult to find. So we generally, anytime you find yourself copying and pasting code or have exact copies like this, we want to sort of factor it out into 1 spot. So what we want to do instead is just have one version of this at the end. So go ahead and type this version, the one where we just have price is at the end. Does anybody see the potential problem with this? Enter in an invalid value and tell me what happens.
Get a price at the end.
Yeah, even though it's invalid. So we don't really have the tools to really handle this in a great way, especially because this is supposed to serve as the launching point for your assignment. So I'm just going to give you a piece of magical code that makes your program stop. Okay, we'll as we get into the semester, when we learn things called functions, we'll understand how it works. For now, just put this right here, return 0. And what that'll do is that'll make your program return early. And so if you've entered in an invalid input, it'll never even get this far in the code. I don't want to really, it's a little too early to explain this. It'll make sense in a few weeks. But now we can enter in an invalid value, and it never even makes it that far. It just exits the program early. Okay, any questions? One quick thing I do want to show you, so don't change your code. This is the version I want you to have for your notes, but I am going to break this very quickly. Remember we talked about this, that if you have gaps, so if I did this at 10 exactly, now I have a gap, and what happens if somebody tries to enter in 10, they get invalid input. So you have to be very careful about those subtle details. But, so be good. Okay. Everyone's good with that? So let's go over to the assignment, and I'm going to go a little bit fast because I want you to get some time to start. We're going to do one more very small example. So so this is imagine you're UPS and you're shipping things, and so it's a two-part program. The first part is very straightforward. I give you another rate table, and again, you're gonna there's overlaps, but I want you to see what the types of tables people will give you in the real world often will be not correctly. So you make the executive call. Just make sure that there's no gaps and there's no overlaps. So just like we did in this example. And the base price, so you're going to have a base price and then a speed price. And so the base price is going to be 0 to 2 is $6 per pound and so on. So same thing as before, essentially. But now there's a second part where you ask them, okay, how fast do you want to ship this item? Now I'd say don't have them type in slow, medium, and fast. Have them type 1, 2, 3, just like we do for the choice-based programs. Okay, everyone good on that? And then you're going to take that original base price, and then if it's slow, multiply it by, it's going to increase the cost by 10%. Multiply by 1.2 to get 20%. If it's medium and then fast, let's say overnight shipping, it's going to be 50% more. So we multiply by 1.5. And then at the end, just output the final cost of the final price. Make sense? Okay, so this is going to be your starting point, and the first half of the program is very, very similar. Now remember that you're going to have to reuse that price variable. You don't need to create another variable because you can just reuse price, and you just say price is equal to the original price times 1.1. Does it make sense? So it's not like you need a new variable every time for everything. You can actually reuse variables and increase them or decrease or do whatever you need to. Okay. Okay, let's go through something. Actually, let's do this because we have 15 minutes left in this next example. We're going to get into it next week anyway. It's on while loops. Let's do this. So let's stop 15 minutes early and don't leave, but I want everyone to start on the assignment for 15 minutes because people really struggle with this second half, and I want to make sure that everyone gets that, okay? So